Sketch the graph of the given hyperbola. Label the vertices and foci. X squared over 144 minus y squared over 81 is equal to 1. When we see an equation of that form, x squared over a squared minus y squared over b squared equals 1, this is a hyperbola centered at the origin, opening left and right. Alright, so in this case the A is 12 and the B is 9. We have the center at the origin, the A is 12, the B is 9. So, since it's opening left and right, roughly we're going to get something that looks sort of like that. And the vertices are those 2 points. So, since the A is 12, we would go 12 units left of the origin, 12 units right of the origin. And those are the vertices. So the vertices are at negative 12, 0 and 12, 0. Now, to help us continue with the drawing, the graphing of this hyperbola, we will draw something called the fundamental rectangle for the hyperbola. And so what we do is we now use the other value, that b equals 9, and so from the origin, from the center, we would go up 9 units, and I'm going to use an open point there, down 9 units, and use an open point there. And those 4 points that we've drawn, not including the center, form what is called the fundamental rectangle. And so we're going to draw that fundamental rectangle. I'm going to use dotted lines to draw that rectangle. And now what we do is go corner to corner and draw another line. So go corner to corner, draw more dotted lines, so these diagonals. All right, and the other one going on the other corners. And these lines are actually asymptotes for the hyperbola. And the hyperbola will follow these asymptotes. And so to draw the hyperbola, we start on one of the asymptotes. Remember that we have the vertex here at negative 12, 0. It has to touch that vertex, and it has to then approach the asymptotes. So then the graph does something like this. Hugs the asymptote, hits the vertex, bounces off, hugs the asymptote. And then on the other side, hugs the asymptote, hits the vertex, bounces off, hugs the asymptote. So there's the graph of the hyperbola. We were also asked to find the foci. So then the foci, when we're working with a hyperbola, to find the foci, we will use the equation c squared equals a squared plus b squared. So now be careful, with an ellipse you have a subtraction between the a squared and b squared, but for a hyperbola it's an addition. So then c squared would equal 144 plus 81, c squared would equal 225, and that implies that c is equal to 15. The foci are located within the branches of the hyperbola. And so then the foci would be at, from the center, go 15 units inside, go 15 units left, go 15 units right. So then the foci are at negative 15, 0 and positive 15, 0. Let's look at another example. Sketch the graph of the given hyperbola. Label the vertices and the foci. Now this one's not in standard form, right? We have 8y squared minus 72x squared is equal to 288. So like we did with an ellipse earlier in this section, we'll divide through by the 288. And that will give us the equation. After we do some reducing, we would have y squared over 72. I'm sorry, that's y squared over 36. Minus x squared over 4 is equal to 1. So now when we have the equation of the form y squared over b squared minus x squared over a squared equals 1, this is again a hyperbola centered at the origin. But now notice the order is different than the previous one. In the previous example, we had x squared and then a minus y squared. Here we have a y squared minus x squared. This will open up and down. And so a rough sketch would look something like this. And the vertices are those points at the bottom and top of the branches. So we have b is equal to 36, b is equal to 6, and a is equal to 2. So from the center, 0, 0, I'm going to go up 6 units, that's a vertex, down 6 units, and that's a vertex. So the vertices are at 0, 6, and 0, negative 6. Let me draw the fundamental rectangle. From the center, go left 2 units, open point. From the center, go right 2 units, open point. Draw the rectangle. Use the rectangle to draw diagonals that are the asymptotes of the curves. Actually, curve. It's a single curve with 2 branches. Draw the hyperbola. Hug the asymptote. Hit the vertex, bounce off. Hug the asymptote. Hug the asymptote. Hit the vertex, bounce off. Hug the asymptote. Let's find the foci. C squared is equal to a squared plus b squared, so 4 plus 36. C squared is 40, so c is equal to the square root of 40, which is approximately 6.3. Recall that the foci are inside the branches of the hyperbola. So then we'd have a focus here and a focus here. And so then the foci are at 0, 6.3, and 0, negative 6.3.